All right, welcome to Introduction to Embedded Systems. Today we're going to talk about two aspects. One is interrupts and one is state machines. And I really need to introduce both at the same time. So I think I'll need to do this. So for a trip to the prize closet, I need somebody to, I need two people to help be part of a demo. So how about my ET students? You never volunteer for anything. Come on, come on. You already get a trip to the prize. That's right. Come on up, come on up. And Mr. Yeah, you. Me. Yeah. You haven't done anything yet, have you? You have not?
Go ahead and
All right. And you know, there's a great trip to the prize closet. I have this nice little LED light bulb thing that looks really cool from Duke Energy. So yeah, I think you need to get one of these. All right. So this is what they like about TV land. All right. So I'm going to do some work, and every so often I'll need to do the following. All right. So let me set the rules up here. So my rules are as follows. I'm going to have, I forget Jeremy. All right. I'm going to have Jeremy. I'm going to have him count to 15. All right. Just regular seconds, right? And when you reach 15, come over and tap me on the shoulder. Okay? And you are Quincy. All right. So Quincy. You guys snickered before. Quentin.
I try to pronounce it right and people get it wrong, but when people say Quentin, that's not how it's spelled.
How about that?
That's perfect.
All right. See? I've been to college. I got a degree. I know how to spell. Sometimes. Quentin, I'm going to have you do the following. I'm going to have you, this is going to be more interesting, all right? I'm going to have you walk up the stairs. Just walk at a regular pace. And then walk down and back. And tap me, I should say, tap me on the shoulder. And tap me on the shoulder. And by the way, after you do that, I'll probably tell you to do it again, all right? So can you do that? All right. Don't hold it. You're right here. All right? So stand right there. You're Jeremy. You're Quentin. You can stand right there. Yeah, well, you're going to go up those stairs, so that looks better. Yeah, those stairs are good. Just walk up casually, walk down casually. All right, so I'm a processor. I'm a Renaissance processor. That means I'm the best in the world, right? Or at least the most number in the world. So my job as a processor is to teach you a class. So what I'm going to do is I'm going to have these two sub-processes actually do something, and then they're going to interrupt me when they've done their thing. All right? So the whole idea is that I'll be able to teach quite a bit of the class, but every so often I'll need to service them. In other words, tell them what to do. But it's really important because it's really important for Jeremy to count to 15, and it's really important for Quentin to walk up and down the stairs. All right? Too bad we can't get that in the video. Wouldn't that be funny? Walking down the stairs. No, don't turn it. All right. All right. So, as a processor, what I do is I'll say, I've given you the instructions. I've given you the instructions. Start. You can count out loud. All right. So, this is the lecture on interrupts. Interrupts are pretty natural in a microprocessor. Thank you very much. Keep coming. And in this example, what I'm doing is I'm talking about two different things going on. So Jeremy's a counter over here. He might be counting up a specific event. Oh yeah. I'm counting them up as I go along. Go ahead. So as a part of this system, I have two separate things going on. Continue. And what I'm doing is I'm keeping track. So they might be doing some really useful work that I need to know about. For example, Jeremy may be an event counter. Very good. Jeremy may also be a clock that runs the time of day clock. Continue. And the time of day clock will tell me when a second has passed. And so I'll make a tick mark. Continue. And I'll make a tick mark say what has passed. He's like hardware running, right? Like the timer. I only care about when something important is happening. Continue on. And so I will keep track of what he is doing. And that's a nice thing about this is that, continue. That's a nice thing about this is that the hardware is running, continue, without the software needing to even worry about, what time is it? What time is it? What time is it? What time is it? Kind of like you did with the data communications. Instead, you're going to use something that doesn't use so much polling, continue, that will only interrupt you when you have to. Because if I were just sitting here saying, is it time yet? Is it time yet? Is it time yet? I wouldn't have time to do anything else. Continue. Continue. Poor Quincy's over there saying, how long do I have to do this? I made sure to select the guy that was at least somewhat healthy as opposed to me. I'd be sucking wind by now. Right? You can continue on. Not saying that you're not healthy, And so I'm waiting for one situation where there might be two people coming at the same time. Oh, so who wins? So both of them were trying to, okay, thank you very much. Oh, by the way, here, trip into the prize closet. If you think these prizes suck, you're welcome to go grab something else. Ooh, the football's hard, it's not a squishy ball. Oh, yeah, okay. I think you're doing that just to keep me from nailing you later, right? So, in this last situation, you saw that both Quentin and Jeremy came to me at the same time. All right? One of them's going to have to get priority over the other, right? And so this is the motivation for what we're going to look at for this section now. It's called general interrupts, or it's called interrupts and then priority associated with this. So, again, as a poll, how many of you actually are pretty aware of what interrupts are? All right, so quite a few of you, but not necessarily everybody. So what I'm going to do is I'm going to cover another topic right now, which will then help us to understand interrupts. And the first thing I'm going to cover is a state machine. Now, you're probably all familiar with state machines associated with hardware, like digital logic systems. Well, I'm going to look at something that is just complete system. In other words, it involves both hardware and software. So let's take a look. So my first demonstration, or my first concept, and this is with respect to a typical embedded system that many of you may have actually touched today. How many of you touched other than your phone, an embedded system? And this is, of course, lecture 19. And our embedded system is going to be a snack food machine. Oh, what the heck? I'm gonna mix it up a little bit. The specific one I'm going to look is a drink machine. I'll do an easy one. That's an easy one compared to a snack food machine, because in most snack food machines, the price is different. So in this one, I'm going to assume that all the prices for the drinks are the same. So sorry, no cans of Monster in it, just bottles of soft drink. All right. So what are the possible things that a soft drink machine could do?
Take change.
All right, take money.
Steal money.
And I heard something else somebody said.
Drinks, dispense drinks.
Dispense drinks.
Do correct change. Return all change.
Return correct change. If you give it $2 bills and a drink is $1.25, it'll return 75 cents. Anything else?
Detect counterfeit notes.
Ooh, you gotta speak louder. I didn't hear that.
Detect counterfeit currency.
Okay, detect money. Denominations. Coin and bills. Yes?
Detect invalid currency.
Ooh. Reject invalid currency. Yes?
That one sold out.
Ooh, at least indicate on the, indicate, I'm going to assume that this is not connected to any network, because I need to make this a really easy example.
Are there any bottles?
Are there any, what?
Are there any cans of to be delivered, or it is empty?
I guess I'm not understanding. Any cans to be delivered?
Saying whether or not it's sold out.
Oh, whether the whole thing is sold out? We'll just indicate when sold out. And again, we're working with bottles, so.
I think that's good.
That's good. I like that. That's good. Just for grins, I'm going to add another one. I'm going to add theft, damage, indicator. This is where I give the example of what I remember from my college years. I was sitting in a study room that had a couple of snack machines, and as I was there, a couple of football players came in, literally turned a snack machine upside down. They both picked it up, or they three of them picked it up, turned it upside down, shook it a little bit to get all the stuff to fall, and then they set it back up, and then everything just fell down to the little door. They took out everything, and they left. So from that respect, I want to add a little bit of theft deterrent, because I don't need to make a couple of football players fatter. All right? Let's see. Anything else I want to put here? That's pretty good. So, if you think about your typical snack food machine, what is happening with that machine nearly 99% of the time? It's sitting idle, sleeping, not doing anything, right? So, maybe it would be good if we identified some states that this soft drink machine could be in, right? So let's think about some states for this machine. So what could a state be? Oh, we already said one, right? Which was what?
Taking on.
Said I. All right, that was the easy one. Is it the taking money state? Well, maybe I should step back and say, in our world, states will be something which indicate basically a condition that this machine is in. And to transition from one state to another will require some sort of input or some sort of event to happen. All right? An event to happen could be, I'll give an example for a washing machine. Washing machines nowadays are pretty much all electronic. Anything you buy today at least has a microprocessor in it. So it needs to, when it washes clothes, it's going to run the wash cycle for a certain amount of time, right? 15 minutes? Well, how does it know it's 15 minutes? You set a timer, right? So the timer will be set for 15 minutes. And so it'll just keep on doing its washing thing. And let's see if we can get this on video, this washing thing, right? All right, never mind. And so this washing thing will go on until a timer, hey, you've heard of a timer before, right? We already did it in the last lecture. Will tap the microprocessor on the shoulder, oh, you've seen that already, right? And say, your 15 minutes is up. And in that case, well, gee, it was in the washing state, and maybe it'll go into another state. Maybe the drain the soapy water out of the washing machine state. All right? So let's go back to our example of a drink machine. What are some of the states that might be existing there based on what potential inputs could be? So somebody, I think, set it up here. The what state? The money inserted.
If it is correct. then-
Pardon me?
If the money inserted is, if it is correct, then it needs to be transitioned to the other state.
Well, don't forget, if you're inserting money, right? Your process or your code can do the validation and stuff like that. But at least you're in a state that says money was inserted. You can even have a money inserted state of 0. You put in a coin, right? That's, let's say, Canadian. And it is, or a rupee. I think half of you will understand what that is, right? And so you put in a rupee and the drink machine says, what the heck is this? And it'll just spit it back out. And do you go back to idle, or should you stay in the money received state? Oh, I don't know. That's an interesting concept, because if you're already awake, if you're in idle, you're kind of sleepy. If you go to money inserted, that means you recognize there's somebody nearby. If you stay in that one, yeah, we'll look at that later. All right, what's another one? Ooh, dispense. What do you think would cause you to go to the dispense state? A button press for a drink. Okay?
And correct.
There are two.
I had enough amount of money, but is the enough amount of money a state, or is it a process that you can check? Probably a process you can check. All right. So we like the dispense state. That could be one of the things that you do. All right. Oh, dispense drink.
Return to idle state.
Oh, you want to return? How about this? Dispense drink and return. How about that?
Or you change your mind and then one thing. You have to change those.
All right, change return state. You know, somebody said this earlier. I like that, what they said. You wanted a state for validate, right? So, I'm gonna have a validate state. I like that.
What do you mean, is that just like saying that you chose the right drink?
That will probably be something where you will check to make sure that the drink is in stock and that you have enough money. How about that? That seems pretty reasonable. All right. So, we have, that's a nice number, 6. You question?
Well, wouldn't you want your theft state?
Ooh. A theft state. So we'll call it a theft
Lockdown.
state. Lockdown. I like that. We'll call it lockdown. Oh, I'm a positive guy, so I'm not going to lock down. I'm going to lock up. How about that? Because that's what my prepared notes say. Right? So interesting enough, here we've talked about on your own, you came up with 6 states, and in my example, I have 1, 2, 3, 4, 5, 6. I have 7, but that's for my snack food machine state. Because I made it a deal that for the snack food machine, if you pressed a button in the idle state, it would tell you how much that is. So, you know, that's something a little bit different. But we're assuming that everything's the same to make this a little bit simpler. All right, so we have all these states. You got that? What are we going to do with respect to our machine? Well, anytime you start up, you always start up in what's called the idle state. And anytime you draw something and you start in the idle state, you start with that. All right? And oh, by the way, if you give an idle state and you don't have the initial arrow like that, you'll get points off. The idle state just says when you power up where you go. And that's important because you don't want to enter or power up the machine in the vend and return change state. Because that would be really bad because then, or the, in the vend and return change state, because then something would be vended and money would be randomly spit out, all right? You laugh. Some of the first original electronic machines actually had this little problem. You can get it to randomly vend things by actually wiggling the plug in the outlet to give it power and not give it power, to basically have it restart, because the engineering was done such that it didn't open up in the idle state. So we'll always want to start with the idle state. So we had another one of these states here, and that was, we'll do the easy one, alarm and the lockout. What would cause you to transition from the idle state to the alarm and the lockout state? All right? So we all agree some sort of sensor. We'll call it the accelerometer sensor. You know, I don't like, you know what, something keeps doing this. Is that easier to read? Which would be easier if this were autofocus. I was going to say embedded sensors. So, what's another state we could include? That's an easy one. Money inserted, how about that? So how would you go from the idle state to the money inserted state? You would insert money. Okay, good. By the way, to make this really simple, let's just say it accepts only coins. That makes life really easy, especially those really annoying $1 coins, right? Now, can you think of any way that you would go from the money inserted state back to the idle state?
Cancel.
Would you go directly from the money inserted state to the idle state?
No.
The validation.
Return the money.
You would go to the return state. I like that. So let's go the return state. And what would cause you to go from the money inserted to the change return? The return button. Would you ever want to have a timer do that? Because some machines I know will actually, if you don't do anything for like 2 minutes, it'll actually return your money. Yeah, let's not do that because that makes it really difficult. And what would cause you to go to the return, or from the return state to the idle state?
All the money has to be returned.
Money dispatch.
Any input?
Change.
You can go to alarm lockup stage from any stage.
All right, so in this case, the return, change return, in the change return state, you would actually change or return your change, and there would really be no input to go to it. So there's no real input, and so what would cause you to go from one to the other would be anything else, right? Oh, by the way,
How do you deal with the alarm in the lockup state? Will it be
oh yeah, how do we deal with leaving the alarm in lockup state?
Yes, sometimes you can come down.
From any stage, you can go to the alarm lockup stage.
Oh yeah, from any state, you can really go to the alarm state, can't you? Well, do you really want to do, well, yeah, I guess you do want to do that. Oh, man, this is going to be really ugly, isn't it? I hope I did this really good so that there's no really wonderful stuff going on. By the way, when you're in the idle state, can you hit the return button? Yeah. Where would it send you? Go back to it, right? Now, I could just go ad nauseum and finish this up, but what I want you to do now is to turn to your neighbor and for the next couple of minutes, finish this up. All right? So we can pause. All right? Go ahead, you got a question.
Say the machine's unplugged and gets flipped upside down and turned back on, how would the alarm lock up?
Oh, wow. Good question. Let's say you're powered off, right? This is a good question. If you are building an embedded system, right, and you're assuming that you're going to run with wall power, would you ever want any sort of battery backup?
Yes.
For dispensing or just for operation, clock, security detection? Probably security detection and clock and stuff like that, right? So, you know, a good designer will put in a battery. Well, I mean, if you have a security system at home, you have a battery backup. You don't dispense drink, but you have it there to lock up certain things. And usually when you power off, very often those machines just kind of like put a some sort of solenoid lock on all, you know, where you can't put your hand in and stuff like this. All right. You had a question to ask?
Yeah, for the validate state, when it's checking if the drink's in stock, when it says it's not in stock, would it ask for a button push again? Or
Oh, good question. When you're in the validate state, in In other words, you press the button saying, give me something, and the process determined if it didn't have enough money, what state would you go back to? Or would you go to? Probably to insert money if you didn't have enough money, right? And so you probably also have to put in some software to say display something. Right? All right, question up there.
I was gonna say your power mode, if the power goes off, I don't think it really matters because then it's not really gonna function. And I'm more worried about damage to the device than I would be the actual product of the device.
Yeah, and that's often why, you know, you see all these warnings saying, don't tip this over, don't stand on it.
Yeah, it's still good.
And they lock them to walls, and they do everything they can to keep you from sticking your hand up there and grabbing crap. You notice the new design now for drink machines is to almost robotically, you know, move some little conveyor belts and actually bringing it to a different place. So there's no way you can physically put your hand in the machine and get anywhere near a soft drink. There was on some TV show where they had to go back and some forensic, like CSI or something like that, right? However, it can't be anything like I experienced when I was at IBM. One of my first days, a guy I shared an office with, all of a sudden I heard him screaming out in the hall, and then bam, 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 and I run out and I find he had put his feet in the dispenser of food for a snack machine and stood up on the shelf where where you put your hands in to get the food out, and he was standing up there grabbing the top of the machine and shaking it back and forth. So I guess in that case that would be the, by the way, he was also 6'8". So you can imagine in the quiet halls of IBM, somebody just shaking the crap out of a machine and making lots of noise. It was not well thought of. All right, so one thing that we were looking at doing is finishing this up. So I'm going to take your recommendations. I kept on hearing you guys saying, oh yeah, let's do this and this and this. Well, I know for sure, we have how many states did we say? 1, 2, 3, 4, 5, 6. We're missing 2, right? So one is the validate, and the other is dispense and change, right? So, from what state do you go to dispense and change? Only the validate state, right? And what would cause you to go from that state to another? You know, if the money is greater than or equal to item, right?
And items in stock.
Oh, and item in stock. And so, if you were in the validate state and this was not true, then you'd go back here. Or item not in stock. And what will cause you to go from the money inserted to the validate? All right, button press. By the way, would you ever go from the validate state to the alarm and lockup? Oh, yeah. And the dispense and change? Oh, yeah.
I have a question.
Yes?
Why do we need to go from validate to alarm? Because if it's only going to be there for one clock cycle, is there really a need for that? It's automatically, it's never going to stay in that state.
All right, the question is, if it's not going to be in this validate state at any time, or for very long, would you just ignore that option?
I would put it in.
Can you save money?
No.
Can you think of a situation where it would be bad to not go from the validate to the alarm and lockup state? What if somebody detected a flaw or a situation mechanically that when you hit, immediately as you hit the select button, you start shaking the machine like hell, and you can be guaranteed to dispense 5 drinks
In one block.
I'd be doing
in
that
1
all
watt
the time.
cycle. Because it's a mechanical thing. Because you are releasing one of the solenoids that allows something to be dispensed, but by shaking it at that exact time, it could allow several to do it.
I like it.
It also makes it a lot easier if you do it from every state.
After dispense change, it must go to the idle state.
All right, so after you dispense the change and the drink, you need to go to the idle state, right? And what would cause you to do that?
RNC will be logged in the state.
You could actually say something like
I see.
sensor of a drink, right? So you can have something in the way that detects if something, like breaking a contact that it goes down. Yes, question?
Don't you ever come out of the alarm?
Alarm lockup.
Oh, yeah, we haven't decided how to come out of the alarm state, have we?
You stay in it.
All right, so the answer to get out of the alarm and lockup state is, heck if I know. This will be something that you can decide on your own. How about that? So I'll leave that up to you. You never know when you might have a homework assignment or a quiz or an exam question that might ask you to write a state diagram for a snack food machine or something, or a washing machine or something. So is there any state transition we're missing? Money inserted to alarm is up there. I got an idea. What if you insert some money, right? And inserting more money will do what?
Great. Uh-oh.
Now there are other aspects of this too. For example, what if you're in the change return state? What do you do with a return button press? When you're in a change return state, what do you do with a button selection for a drink? All right? So those are all the types of things that you have to be prepared to address. And we're going to look at that when we go into great detail about how to actually create our state machine in software. And I'm trying to think if I have enough time to address it. But at the very least, I could start with this. And in fact, as a type of quote-unquote homework assignment, at least to get you to think about this, right? Think about, well, I'm gonna go a little bit longer and I'm gonna talk about different things. All right, so what were the sensors we identified? Or for that matter, anything that would cause you to change a state. Let's list all the things. Accelerometer. What else? All right, coin return button.
Currency audit.
some sort of coin insert, right? We decided to make this easy and just do coins and not dollar bills. Or $5 bills for that matter. What else? All right? And we call this button selection. What other types of inputs did we, or sensors of any sort did we say we would have? All right, sensor of drink.
Detecting the stock level.
Do we want to do that mechanically, or do we want to do that electronically? Or do we want to do it with software? Pardon me? This is interesting.
Both ways, I think, and you can find that. But no, you can sure.
I'm just going to put down stock level, all right? And we can go into more detail later for how we're going to use that sensor. Anything else?
Make sure you return the right amount of coin.
Return the right amount of coin. Do we want to count it, or we just want to believe that in the 25 cents stack that you just spent 25 cents? Pardon me?
Make sure you have enough coin.
All right, so, yeah, we're getting into a little bit more detail than I want to. How about this? We're going to go with this? All right, so, what you need to think about, and this is the motivation of later on, what we call interrupts, right? So what would create an interrupt in our system?
Any of those sensors.
All right, so we can generate an interrupt by a,
A shake level.
a specific shake level. All right? And we could just call that hardware. At a certain level, then a pulse will come through. How about that? A shake level. This is going to be a pulse. So this will be digital. All right, coin return button. This will generate a some sort of digital interrupt. Coin insert. This will generate some sort of digital interrupt. But this will also be able to identify the size. So we'll have some mechanics in there that will accept nickels, dimes, quarters, and dollar coins. We'll ignore the pennies and the half dollars, right? Button selection will actually be digital, and it will be able to tell us the specific product. The drink sensor will be able to tell when something has passed out to the customer. So this also looks like some sort of digital sensor. And then the stock level,
Can we just do a PLC dev switch?
well, I've seen situations like this before, that if you pass, or if you have like something, and you weigh it down, it makes a connection, right? It's like a reed switch. And when there's no product on top of that, then the switch is open, otherwise it's closed. Do we want that to be something that's interrupt-based? Or do we want to check on that? It sounds like something we might want to just check on later, right? So is that going to be an interrupt? No. Because that looks like something that during the validate state, you can just go check. That one product isn't there. Yes, sir?
Do you really want it checking, like, after they put their money in, and stuff like that, or do you want it to just automatically display that it's sold out?
Well, the only thing that we'll do is we'll tell people that everything is sold out. Everything is, well, you know, and at this point in time, does it have to interrupt? We can deal with that later, but does it have to interrupt the system when it's empty? Or can you have something in there that will check it every so often?
It would just have to check before that, I guess, before the validated state, because if you went into the validated state and it's like it automatically went to dispense, then it would, you would think about,
Yeah, and so what he said, or the camera may not have heard this, is that you probably want to do it before validate. And actually, this is something that might be really good in the idle state, right? Because in the idle state, what's it doing? You know, it's what we call twiddling thumbs, right? Not knowing what it's doing. Well, why not say, do you have quantity there? Do you have quantity there? Do you have quantity there? Do you have something there, something there, something there? And then it could store in its own little array what is there and what is not, right? That would be a nice thing for it to do. So the motivation I wanted to say is, those are the things that are going to be serving as interrupts. So now we're going to write what we call interrupt service routines, or software that can be called whenever that button is pushed. And so with that in mind, we'll call this a class, and we'll revisit this design on Monday. Thank you very much.